Hello and welcome to another tutorial. Today we are going to solve questions and SAT in geometry, and I'm going to show you how to solve these questions. And we have the question 1, and it says that if a is greater than 1, what is the slope of the line in the xy plane that passes through the points a squared, a to the power 4, and a cubed, a raised to the power 6. So let me start by talking about what we mean by the slope of a line. Okay, now the slope of a line determines how steep the line is, or how steep or gentle the line is. If you draw a line and the shape is like this, we say that the line has a positive slope, and if the line descends this way, we say that it has a negative slope. So if you look at the first one that we have here, this implies that as the coordinate s increases, the values of x increase, the values of y also increase. So that is what we have here. So if I draw a graph, let me draw a simple graph to illustrate what I'm saying here. And we have 0 here, 1, 2, 3, 4, and here we have 1, 2, 3, 4. Now if I draw a line this way, this line has a positive slope. The slope is positive, so we say it has a positive slope. Now this line has a positive slope because if I indicate any point on the line, say let me start from here, this point. Let us assume that this point is the point 1 1, because we have x to be 1 here, then we have y to be 1 here, so x is 1 1 here. Now if I come to this point, that is where x is 3. In other words, if the value of s increases by 2 units, that is from 1 to 3, and so this point or this coordinate goes that way. Okay, good. So you can see that if I stand here, if x is 3, the value of y also increases from 1 to something else. If I am here and x is 4, the value of y also increases. So with a positive slope, as the value of x increases, the value of y also increases. So the two coordinates, the values of the two coordinates increase. That is, if we have such a situation, we say that the line has a positive slope, or we also call it gradient. So you can call slope also gradient. It's the same thing, and normally we use small m to represent gradient. Now if you have this shape, that is, if it's like the line is descending with this one, if I draw the xy axis here, or the xy plane, that is the x-axis, and of course that is the y-axis, and we also call this line the line y equals 0 because there is no value of y here, and we also call this line the line x equals 0. That is, the y-axis is also called the line x equals 0. Now if you look at this, if I put 0 here, 1 here, 2 there, 3, 4, and here 2, let me start from 1, 2, 3, and I draw a line here. Now if I pick any point along this line, for example, if I pick this point, its x coordinate, if I trace down, let us say it's 4, so I have 4. If I trace the y, it is 1, so we have 4, 1. And if I come over here, you can see that the coordinates of x is decreasing, because here it was 4 and here 3, so it has decreased by 1. But if I trace it to the y is rather increasing, that is from 1 to 2, and here it has decreased from 4 to 3. So you can see that that is actually what is happening here. So when we have a situation like this, we say that the line has a negative slope. So that is the shape of a line that has got a negative slope. So if the shape is like this, then we say that it has a negative slope. Now we also have a line which goes horizontally like this, and if you have such a line, then the slope of this line is 0. So let us look at what I'm talking about here. If I draw the xy plane this way, that is the x-axis and that is the y-axis. So if here is 0, let's put some coordinates here. So let me say 1, 2, and just 3 here. And because the line is going to be horizontal, it will of course be cutting the y-axis here. Now if I draw a line to pass through the points where y equals 2, we call this line the line y equals 2. So this line has no x, or let me say that the coordinate of x here is 0. It is the line y equals 2. This point here, the point here 2, is of course it is 0, 2. It means the x is 0 and the y is 2 here. We are saying that the slope of this line is 0, and we are saying so because the formula for finding the slope of a line is the slope is y1 minus y2 over x1 minus x2, or we can say y2 minus y1 over x2 minus x1. Now when you say y1 first, you say x1. When you say y2 first, you say x2. Now what are these x1, y1, y2 and those kind of stuff? Now to calculate or to find the slope of a line, you need 2 points. So I just assume that the 2 points are x1, y1. That is the first point. When we say a point consists of x and y coordinates. So that is the first point. And I assume that let the second point be x2, y2. So the slope is just the difference of the y coordinate. So you take the y coordinate and you subtract one from the other. So if I pick the y1 first and subtract the y2 from the y1, then if I come down here, I have to do the same thing. That is, I have to pick x1 first here and subtract x2 from x1. So I'm going to get something like this. Or should I pick y2 first? Then I also have to pick s2 first here. So that will be s2 minus s1. So these are the correct formulas for finding the slope of a line. If you find the slope of a line by picking, say, y1 first here, but when you get here, you pick s2 minus x1, that is wrong. We don't do this. This is not the correct way of finding the slope of a line. So, but why do we say that the slope of this line is 0? Let us try to have a look at this way. You see, if you look at these points here, let me pick any 2 points on the line to find the slope here. Now if I pick, say, the point here, it comes down here. So the x is 1 and the y is 2. So the first point is 1, 2. The s coordinate is 1 here and the y is 2. If I pick another point here, the s coordinate is 3 and the y is 2. Now if I want to find the slope here, let me just calibrate or label my points. I'm calling this the first point, so of course this is the x1 and this will be my y1, and I'm calling this the second point, so this will be my x2 and my y2, and I'm going to use y1 minus y2 out of x1 minus x2 here. So this is what I'm going to get here. Y1 is 2 here and y22 is 2 here. X1 is 1, x2 is 3. So because the y coordinate will be the same, because of course the line is passing through the y, the same point, so the y coordinate will be the same, and that will give a 0 numerator, and if anything divides 0, we get 0. So that is the reason why we are saying that the slope of this line is 0, because the y coordinates are the same. Now there is another one that I have to talk about, that is when we have a vertical line. Now the slope of a vertical line, how should I even put it? A vertical line has no slope. Or we can say that the slope of a vertical line is undefined, or we can say it is infinite. The reason is pretty simple, because in math you can't divide by 0. If it is vertical, we are of course going to get the same s coordinates. Let me draw a line here and show what I'm talking about here. So if we draw the xy axis here, and we have 0, 1, 2, 3, 1, 2, then it goes on like this. And if I draw, a vertical line through here, let me pick any 2 points on this line. I'm going to pick this point here, and I'll pick that point here. Now this point has the x coordinate, of course, it is coming down here, so 2, and the y is going there, so 2, 1, so that is the first point. And this point 2 has the same x coordinates, that is 2, and the y is going here, and that is 2. So if I want to find the slope using m equals y1 minus y2 over x1 minus x2, that is what is going to happen. Let this be my x1 y1, this is my x2 y2. Of course I'm going to get y1 here is 1 and y2 is 2. So the numerator is okay, but there's a problem down here, that is the denominator. X1 is 2 here and x2 2 is 2, so I'm going to get 2 minus 2, and I'll have -1 out of 0. So it's like saying that if 0 people divide -1, I mean 0 is not a counting number. We cannot say 0 divide something, so that is undefined, and that's why we say that the slope of a vertical line is non-existent, or we say that it is undefined, or we say it is infinite. All right, let us go back and solve our question. All right, so as I said earlier on, what I'm going to do here is that I'm going to guess the value of a. We have a squared, a raised to the power 4, and we have a cube, a raised to the power 6. So these are the 2 points that lie on the line, and we are asked to find the slope of this line. I don't know the value of a, but a quick way to solve this, is that you guess the value of, a. So let the value of a be, what is it, 10, 9, 7, 6? If I'm going to pick 7, 6, I cannot be finding 7 raised to the power 4, because it is really going to be a very huge number. Why not pick something that is very, very conducive? Why not something like 2? Of course, when you pick 1, there will be a problem, because if you pick 1, the x values are going to be the same, and of course that will be undefined. So I think 2 is the least possible number that I can pick here. So what I'm going to do is that I'm going to substitute 2 into a. So when I do that here, what am I going to get here? I'm going to get 2 raised to the power 2, and if I do the same thing here, I'm going to get 2 raised to the power 4. So that is the first point here. If I do the same thing here, what am I going to get? I'm going to get 2 raised to the power 3, and if I continue to put in the value of a here, the value of a, that is 2, I'm going to get 2 raised to the power 6. Now what I'm doing here is that I'm trying to guess the value of a. Just put in any number, don't put in a huge number that you end up suffering. All right, now let me try to understand this. 2 raised to the power 2 means that 2 multiplies itself twice, so 2 raised to the power 2 is 2 times 2, and that is 4. And 2 to the power 4 means 2 multiplying itself 4 times, and that is 16, because 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. And 2 to the power 3 means 2 multiplies itself thrice, and that is 8, because 2 times 2 4, and 4 times 2 is 8. And 2 to the power 6 is 64. 2 multiplies itself 6 times. 2 times 2 4, times 2 8, times 2 16, times 2 32, and times 2 64. And you have 1 2 3 4 5 6. So that gives you 64. So what are we doing? We are finding the slope, right? So the slope, or we call it the gradient. We can also call it the gradient of the line, and normally we use small m to represent that. So that is equal to, let me use my y1 minus y2, or okay, let me take y2, because I'm going to use this as my first point. I don't want negatives here, so I'm going to use y2 minus y1 out of x2 minus x1. So let this be my first point, so that means this is my x1 y1, and let this be my second point, so that means this is x2 y2. So y2 is 64 and y1 is 16. s2 is 8 and s1 is 4 here. So if I subtract 16 from 64, what am I getting? If this was 14, then I'll be getting 50. So you take 2, so I should get 48 here. Okay, I'm correct. Then you divide it by 4, and 4 into that, 4 into 4, 1, 4 into 8, you have 12. So 4 goes into 48, 12. So which one of these is giving that 12? Let me check it and see. So if I put 2 here, I'm going to get, am I doing the right thing? I'm getting the slope here to be 12. Okay, I'm doing the right thing. Is D. Okay. So which one of these is giving me the number 12 or the figure 12? If I look at these, well, I can guess it. I think it has to be D, because these will not give me 12. But let me try to tell you why I'm saying this. If I pick the first option, I have negative a to the power 3 plus a squared. So there is negative a to the power 3, that is 2 to the power 3 here, and I have 2 to the power 2. So I have negative 8 plus 4, and that gives negative 4. So the a gives negative 4, and that is incorrect. B, I have negative 2 raised to the power 3 minus 2 raised to the power 2, and that is negative 8 minus 4, and 2 negatives give negative here. So if I have negative 8 and have negative 4, it's like owing negative 8 and owing 4 too. So that's going to be negative 12, and here I had 12 here, so that is not correct. Let me check the C2. The C, I have a cube minus a squared. So I have 2 raised to the power 3 minus 2 raised to the power 2. 2 to the power 3 is 8. 2 to the power 2 is 4. 8 minus 4 is 4. That is also incorrect. So of course that makes D the correct option. I have a raised to the power 3 plus a to the power 2. So I have 2 to the power 3 here, and I have 2 to the power 2 here. 2 to the power 3 is 8, and 2 to the power 2 is 4. 8 plus 4 is 12. So this makes this the correct answer. So by guessing, a value for A and finding the slope using the points and trying to see which of the options satisfy what you had, you can actually predict the correct answer. Of course, another way is to solve it algebraically, and that is possible. Now you have been given these 2 points. You have a squared, a to the power 4, and you have a cube, a to the power 6, and you asked to find the slope. So it's very straightforward and it's very simple. So just call this your first point, so that is x1 y1. Call this your second point, that is x2 y2. So the slope is going to be we can have y2 minus y1 out of x2 minus x1, and of course that is going to be m is going to be my y2 is a raised to the power 6 minus my y1 is a raised to the power 4. My x2 is a to the power 3, and my x1 is a to the power 2 here. Okay, and that is going to be I can factorize out common terms here. A to the power 6. A to the power 6 means a multiplying itself 6 times. Of course, here 3, 4, 5, 6. and here a to the power 4, so means a multiplying itself 4 times. So of course, if you look at this, if you compare these two terms, I can get a raised to the power 4. That is, I can get 4 a's in the 6 a's. I can get 1 2 3 4 here, 4 a's out here, and it will be left with still a to the power 2, that is 2 a's. So here I'm going to do some factorization. So I will factorize out a raised to the power 4, that is the highest common factor here, and of course I'm going to get a raised to the power 2 here, and here will be 1. And if you compare a to the power 3 and a to the power 2, the highest common factor is a to the power 2, and I'll have a minus 1. So let me do some cancellations here, and of course this can cancel that, and I'll have a raised to the power 2 left up here. So I have a squared minus 1. So that is what I'm going to get here, because a to the power 4 is a multiplying itself 4 times. So I have a multiplying itself 4 times divided by this, that is a multiplying itself twice. So if there's any cancellation here, I'll be left with a raised to the power 2, and that's why I can see this here. Of course, if I compare these two here, I can still simplify. What you see here is what we popularly call difference of two squares. Difference of two squares. Now 1 is, a perfect square. 1 is the same as 1 raised to the power 2. So I can better write this as a squared, a minus 1, then a plus 1, or divided by a minus 1. And a minus 1 can cancel a minus 1, so that I'll be left with a squared, a plus 1. So this will be the slope of the line, and if I expand this, it is very clear. You see, we get option D, a squared times a, we have a cube, and a squared times 1, we have a squared. So the slope is a cube plus a squared. And if you look at the option D, of course we have a cube plus a squared. So there is another way that you can solve it. If you want to do it, it is pretty simple. So we look at example 2, which says that which of the following is an equation of the line in the xy plane that passes through the point 4, -2, and it's perpendicular to the line this. Okay, so now before we go on here, I want to talk about equations of lines. Now there are several standard formulas for equation of a line. One is the slope intercept form, and that is y equals mx plus c. So if you look at this, that is the equation of a line, and it comprises slope and the y-intercept. So I normally call it the slope intercept form. So the m here is the slope, that is the gradient of the line, and the c is the intercepts on the y-axis. So if I were to draw a line, so let it be the xy axis this way, let me draw a line to pass through here, and this point that you see here, that is where the line cuts this y-axis, that is the y-intercept, and this is the c. So there is the y-intercept here. This line has a positive gradient, so the c that you see here is the y-intercept, that is the intercept on the y-axis, the point where the line cuts the y-axis here. So if you are given an equation like this, for example, if you take this here, we have y equals -4x plus 7. So you can see that the slope of this line is -4, because if you compare this and that term by term, we have mx here, then we have -4x here. The coefficient of x here is the constant m, and the coefficient of x here is -4. Let me say here that m and c are constants. It means they are numbers. So m and c are constants here. And of course, the constant c stands alone, and you can see that c is equal to 7. But this is the equation of a line that is perpendicular to the equation of the line that we are yet to find. Now, to solve this, if you are told that the point 4, negative 2 lies on the line, or the line passes through the point 4, negative 2. If you look at the question, it says which of the following, that is A, B, C, D, which of the following is an equation of the line in the xy plane that passes through the point 4, negative 2 and is perpendicular. So let's take the first point. It says that it passes through the point 4, negative 2, and it adds that it is perpendicular to the line y equals negative 4x plus 4. Now the first statement, that is it passes through the line 4, negative 2. If a line passes through a point, then it means that the point satisfies the equation of the line. So which of these four options satisfies the equation of the line? I'm going to start this from C. I would have started from B, but I'm starting from C because if you look at the equations, you can see that it is, the C and D have, the same gradient. That is the gradient or the slope of the lines of the C and D, and that of the A and B to have the same slope. Now compared to the line here, for example, the question says that if this line, that is y equals negative 4x plus 7, if this is the line y equals negative 4x plus 7, then we are asked to find another line which will pass through a certain point 4, negative 2. It will pass through a certain point 4, negative 2, and also it will be perpendicular. That is, it will be at 90 degrees with the line. When we say perpendicular, it means 90 degrees, or it will meet the line at 90 degrees angle. So we have to find the equation of this line, that is y equals mx plus c. We don't know this, and because the gradient of this line is negative 4, the gradient of the line that will be perpendicular to this will be the negative reciprocal. I'll talk about this more here. And what we mean by negative reciprocal is this, the gradient of this line is negative 4. If you reciprocate negative 4, you have negative 1 out of 4. Let me say this again. I'm saying that if you take the number negative 4 and you reciprocate it, or if you take the reciprocal, that is, if you take reciprocal of negative 4, you get negative 1 out of 4. And after that, if you negate it, you get 1 out of 4. So what I'm saying is that if I add the two words, that is negative reciprocal, it means you reciprocate it and you negate it, or you negate it and you reciprocate it. So we are saying that when two lines are perpendicular, the gradient of one of the lines is equal to the negative reciprocal of the other. So if the gradient of this line is negative 4, then the gradient of this line, that is the vertical line, will be 1 out of 4, because you have to reciprocate this and negate it. Okay, and because of that, I'm going to choose C or D. So I will not even talk about the A and B. So let me start from the C. Now, if the point 4, negative 2 lies on the line, or if the line passes through the point 4, negative 2, then it means it must satisfy the equation of the line. So let me guess that the solution is C, y equals 1 out of 4x minus 3. So if I put in x, that is 4, the point is 4, negative 2, that means x is 4 and y is negative 2. So if I put 4 into x here, am I going to get negative 2 as the y? That is the question. In other words, that is satisfy the equation of the line. 4 goes here 1, 4 goes there 1. So I'll have 1 here minus 3. And of course, if I subtract 3 from 1, I get negative 2. And negative 2 is equal to negative 2. So the correct option here is C. Now I want to say this here. The correct option here is not C, simply because the line passes through the point 4, negative 2. At times you can have a situation where another line passes through this point. For example, if you look at this here, I can draw a line, another line from here, which will pass through this point. You see? So if I put in 4, -2 into this line, it will of course satisfy the equation of this line too. So imagine if the equation of this line was part of the options. So that means that if I had put 4 into this, or 4 -2 into this, the equation of this line, that is the yellow line, it would have satisfied it. So in that case, if I have more than 2 satisfactions, or more than 2 options that satisfy what I am looking for, then I have to go to the next option to find out if indeed that line is perpendicular to the said line, and in this case it is not. So that will give me the option that I want. All right, so that is how you can solve this, and of course you can solve this geometrically. So let us look at these two here. Now, as I did say, we are told that we have to find the equation of a line that is perpendicular to another line, and the equation of that line is y equals -4x. I think -4x, is it +7 or something? Yes, +7. So -4x +7, and that is the line, and we asked to find the equation of another line that is perpendicular to this line. Now let me write it here, or let me say it here. If the gradient, if I compare this to the general formula of the equation of a line, m is -4, and if m is -4, then the slope of this line, which is perpendicular to the yellow line, is 1 out of 4. If that is -4, then that is 1 out of 4. It is as simple as that, because we are saying that the gradient of a line is the negative reciprocal of the other line that it is perpendicular to it. So if there is line A and there is line B, and we are saying that line A and line B are perpendicular, or they meet orthogonally, or they meet at 90 degrees, at the 90 degrees angle, then the gradient of line A is equal to the negative reciprocal of the gradient of line B, and vice versa. So if I'm going to solve this, that is pretty simple. I have y equals, so find the equation of this line. That is the general formula of the equation of a line, and I know the gradient here, so I'm going to write y equals 1 out of 4x. All that I want is the c. So can't I find the c here? The c is the y-intercept. So let me find the c, and I can find the correct answer here. I am also told that the point 4, -2 lies on it, so that means that it has to satisfy the equation of the line. So y is -2, and of course x is 4. So let me put 4 here. I am finding the constant c. So I have -2 equals 4 will cancel 4, and I have 1 plus c. So if I subtract 1 from each side, so I have -2 here, and I'll subtract 1 from this side, and here too I have 1 plus c, so 1 from here, so that I can have my c. So my c will be equal to -3. So this implies that y is equal to 1 out of 4x minus 3. So there is another way that you can also solve this question. Alright, so that is example 3, and that is what we're going to do here. What is the equation of line K in the figure above? Now we have a graph, or we have a diagram here. Let me try to draw straight lines. So I have this. Okay, I think that is better. Oh my god, my line is crooked. Let me try again. Okay, this time around I think it is okay. So if you look at the calibrations or the S that we have here, 1 2 3 4 5 6 7. So we have 1 2 3 4 5 6 7. We have equal distances between them, and here too is 1, so we have 1 1 there. Now where is the line passing? Let me check. 0 1 2 3 4. So we have 4 and 2 here, so the line is passing through here. That is 0 2, and here 4 0. The point here is 4 0. That is 4 for the x and 0 for the y, because it lies on the x-axis. That is the x-axis, and that is the y-axis. And let me see if I can draw a straight line to connect these 2 points. Okay, so that is better. Okay, let's go up here. Okay, now what is the equation of line K in the figure above? First, let us talk about the equation of a line. It is y equals mx plus c, as we've said already, and we have said that m is the gradient and c is the y-intercept. So from the graph we can see that the line is intercepting the y-axis at this point, and we have 0 1. So here is 2, so it is intercepting it at the point where y is 2. So this means that if you look at these answers, it means b cannot be an option, because the intercept on the y here is 4, and d2 cannot be an option because the intercept on the y here too is 4. So these are the two options that can be correct, either A or C. And the next thing that maybe we have to look at is, what is the slope of the line? Is a negative slope, and of course A is a negative slope and C is a negative slope. So let us check which one of these is correct. Now what point is here? This point lies on the y-axis, so that means that there is no x, or the x is 0 here, if you want to see it that way. So this point is 0 2, and here is 4 0. So using the formula of the slope, that is y1 minus y2, then x1 minus x2, or the other way around. Let me take this as my x1 y1, and this is my x2 y2. So y1 is 2, y2 is 0, s1 is 0, s2 is 4. I'm going to get 2 minus 0 is 2, and 0 minus this, we have negative 4. So 2 here 1, 2 here 2, so the slope is negative half. So you can see the slope there, negative half. Therefore the equation of the line is negative half x. Then the slope, sorry, the intercept on the y-axis is of course 2, so it's this plus 2, and the correct answer is the C. So you can solve this question this way by looking at where the line intercepts the y-axis, and also finding, the slope of the line by considering the 2 points on the line where the line passes.